Array. An array is a data structure that stores a collection of elements that are of the same memory size and are stored in contiguous blocks of memory. These 2 points are very important. One is that all array elements will be of the same memory size and they will be stored in contiguous blocks of memory. Generally, when you want to represent an array, you will draw it something like this. Each element will be present in next positions. The point is, it's not just that you are representing like this. Actually, when the array is present in memory, it will be kept in contiguous memory locations. You can imagine an array like this. You have a cupboard or an almirah in which there are a lot of shelves, but all these shelves are of the same size and you are supposed to keep the same type of item in each of these shelves. This is how you can imagine. Or you can think of it like a bookshelf, a horizontal bookshelf in which how will you keep the books? You will keep it one after the other in contiguous locations. This is how you can imagine an array. Then the question is, why is it that all array elements are of the same size and why is it that they are stored in contiguous memory locations? There should be some reason by which it is designed this way. The reason is it is to allow for efficient access. Because all the elements are of the same size and that they are all stored in contiguous locations, it is easier for you to access any element in very quick time. Let us see how this efficient access is done in arrays. Consider this is your array and the first element is kept at address 1000. 1000 is the memory address of your first element. What do you know now? You know that all elements are of the same type. So let it be integers. If it is integer and 4-byte integer, then each of the element will be of 4 bytes. What do you know? You know all of them are of 4 bytes and they are kept next to next in contiguous memory locations. What is the memory address of first element? You know it is 1000. What about the second element? You have to add 4 to this. Then you will reach second element. What about the third element? It will be at 1008. Like this, you can directly find the memory address of any element in array. The advantage is, it is not just that you can access the elements next after the next, but if you want to directly access some other element, let us say you want to access 7th element. How will you directly access the 7th element? You know the memory address of first element is 1000 plus how many elements should you cross in order to reach the 7th element? You should be crossing 6 elements. So you have to cross 6 elements, each of 4 bytes. So what is the final answer? 1024. This is the memory address of your 7th element. So if you want to access the 7th element, you don't have to sequentially go through each element and reach it. Instead, you can directly go to the 7th element and access it. This is the advantage that is provided by arrays. Generally, what you do is, if you want to store any data, first step is you have to identify the data structure. You have a lot of options. You have linked list, you have stacks, queues, trees, heaps. There are a lot of options available. But generally, arrays are your go-to data structures. You will use all these data structures if there is a specific need. But if you don't know if there is any specific need of those, then you generally go for arrays. Array is your go-to data structure. By this time, you know one use of array is to store data. There is something more. If you want to implement other data structures, let us say you want to implement stacks or you want to implement queue, you can use arrays for this, and this is the second use of arrays. If you want to implement other data structures, if you want to implement heap, you can implement it using arrays. If you want to implement queues, you can do it using arrays. Similarly, there are many data structures which can be implemented using arrays. This is the second usage. One more thing is, with array, what all operations can you do? You know there is something called arrays. You know you can access any element directly, but there are many operations which makes array very useful. One is traversal. Traversal means going through each element in the array. That is very simple. Then you can search for an element. You can insert an element. You can delete an element. We'll go through all these operations separately in the coming lectures. One more thing is, till this point I've been showing you arrays, but every time I showed you a single row, that is a single dimensional array, one dimensional array. Arrays are not always one dimensional. It can be two dimensional, it can be three dimensional, it can have any number of dimensions. What is a two dimensional array? Two dimensional means here you are just having one row of elements. Instead, you can have a lot of rows. You can have rows and columns. This is what you call as a two-dimensional array. Similarly, there can be an array of these two-dimensional arrays that you call as a three-dimensional array, and so on. I just wanted to make it clear that arrays are not just about having a single row. The one more thing is, where do you actually use these arrays? You know arrays are having certain operations. You know arrays are of fixed size. You know how to reach any element. Where do you actually use these arrays? I'll just give you one example. You may be already knowing, but still let us go through one example where arrays can be useful. If a cricket match is going on and you want to store the scores of all players, you already know that there are only 11 players in a team. Because of this, it is easier to initialize a fixed size array. What will you do? You will initialize an array which is having a total of 11 entries. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a total of 11 entries. Arrays are generally 0 indexed. We can index it from 1 as well, but generally we use 0 indexed arrays. Here there are 11 entries, and what can you do? If any batsman scores anything, what can you do? You can directly go to that particular index and you can enter the score. If you want to read the score of any batsman, you can directly go to that index and you can access. This is one example where you can use arrays for storage. There can be a lot of situations where you will use arrays for storage. This is an introductory lecture on array. We'll go through each of the operations that we do in arrays, then it will be more clear.